Yeah, okay. Is this up here, and then also it's always on the notes that I post every day. Though I may not have posted yesterday's yet, now that I think about it. All right, so this is using what we did yesterday. We remember our BPA converts over to the logarithmic form of log base B of A equals P. Our BPA log BAP. BPA log BAP, that guy. So if we want to write this in exponential form, what's that going to be for this one? Mm-hmm. It currently looks like this. I want it to look like this. Where are we going to start? The 2. Because my 2 is that base. And then we're going to have our 4, because that's going to be our power. And that's going to equal 16, our argument. Awesome. I was just keeping my ear on. I got a grown-up in there. Yay.
I mean, technically, someone
They don't have their license, their sub-license. Just say, technically, they have to be supervised by someone with a sub-license, which is why only some student teachers have to do that, because those are the ones that get their sub-licenses when we have them.
I know that performing arts department gets at least 1 a year or something like that.
Oh, we had a few, but they've gone to the middle school for a couple of weeks, because they make them do middle school. Yeah.
I don't understand when they do that. At least, like,
The most high school teachers have a license to teach 6 to 12. And so since the license includes that age bracket, they want to make sure everyone's been exposed. Most of us only spend a couple of weeks in the middle school and then we never come back. The people that voluntarily choose to work in a school, we need them, more power to them, not me. All right, on this guy. How do I write this one in exponential form? What's our base? 10. There's not one written here. That means makes this the common log, which has a base of 10. Yes, 10 to the 3rd, 10 to the 3 equals the 1,000. So then these next two are going in the opposite direction. We're taking the exponential form and we're writing it as a log. So on this first one, it's very similar to the one we just did, because we have our log that has a base of 10. Our argument is the 100, and it's going to equal that power of 2. So I could write it just like this. It's not wrong. More often, though, we will write our common log without a base, so we just drop that little 10. These are both technically correct. There is absolutely nothing wrong with this.
Oh, because 10 is one of
because 10 is our common log. So either one of these is 100% accurate. So without a number, it means that we have a 10 there. Because again, mathematicians are a little bit extra. A little bit. I'm so
Just
funny.
a little
Just
bit.
a little. Just a skosh.
Tiny bit, you
Just
know?
a teeny bit. Mathematicians like to make things complicated. We love it. All right, last one in the bell work. This is going to be log with what base? 3. What's our argument? 9. And it's going to equal x. Could we figure out what that value would be? 3 to what power is 9? 2. So log base 3 of 9 equals 2. Oh snap, and you just figured out your first value on a log. Okay, questions on these 4? Cool. So what we're going to do is we are going to look at problems that are set up very much like this, where we're going to be given a log with a base and an argument, and we are going to find out the power. That's the piece we're going to usually find out. So it'll be problems like this, where we're going to say log base 3 of 9 equals, and we got to figure it out. So this is in our notes packet. We're going to do a selection, because some of them are genuinely awful. Most of them are not brutal, but we're going to give them a shot. So I'm actually going to start us with number 2, and then we'll do number 1, just because 1 feels like a lot to start with. I don't like that at first. So we're going to start with number 2. So we have log base 12 of 144. What I'm going to do is I'm actually going to kind of switch that back around, because what we're trying to do is we're trying to figure out what this power would be. We want to figure out what that is. So our base is the 12. Some power, I don't know what yet, that's what we're trying to figure out. And it's going to equal our argument of 144. So 12 to what power is 144? 2. So log base 12 of 144 equals 2. So when we are given a log with a base, we say this base to what power equals our argument. Ooh, there's not one. So if we look at number 1, our base to what power is going to equal 1/8. Think of, or switch it wholly around as needed. So this is 2 to what power is going to equal our argument of 1/8. What do you think? That would be our base. You're talking on number 2? We were thinking through this bit. 12 to what power gives us the 144?
My brain is telling me either
First instinct. So because in order to make something be a fraction, that's when we have our negative exponent. So we know this is going to be a negative. And 2 to the 3rd gives us 8. So 2 to the minus 3, and you can type it in your calculator, 2 to the power of minus 3, and it will give you back a 1/8. That's why I definitely didn't want to start with that one. I like that one being the first. So we're trying to figure this piece out. This is what we're being asked. So we're having our base to what power gives us the argument. So with the negative versus the fraction. The fraction means that we're taking a root. So we don't really want to do that too much.
Number 3 was on our ballot.
So common log of 1,000 equals what? 3. Because this is our base of 10, we're trying to figure out this power to know when it equals our argument of 1,000. That's what we're trying to figure out. And 10 to the third equals 1,000.
I'm just looking at the problems randomly and I just realized 1 and 13 are the same.
Yep,
Oh, that's right. We have a packet.
we
Oh,
do.
Why didn't you use PSD?
Because you don't have to use the packet. I've had people choose not to use it before.
Right in my notebook.
Is it because it could also technically be 1/3?
For 13 and 1? No, that's just typo.
Really?
Yeah. No, because 2 to the power of 1/3 is the cube root of 2. When we have a fraction, the bottom is the index on a root. So,
My friend is what?
I'll show you in a second, okay?
Okay.
Because I'll look at number 6, because number 6 will give us an easier one to see than that. I don't have it up here, but we'll look at it. All right. Let's look at number 5, and then 8, and then 10, and then we'll do number 6. Just so log base 5 of 25 means we're looking for 5 to what power gives us 25? What 5 to what power gives us 25? 2. 5 squared. You were thinking times, not to the power. So same vibe, different answer. So be careful. So log base 5 of 25 equals 2. It equals that power. So when we're starting to evaluate these, we're just trying to figure out what that power is. So let's do 8 and 10. So 8's a little bit harder. We have log base 7 of 343. And we want to know what that equals. How are we going to figure that out?
Calculator.
Say it again.
It's a calculator.
Calculator. More specific, how are you going to use that calculator?
Divide. Would that be?
Couldn't we do
49.
log 7?
Unfortunately, our calculators cannot put in a log base 7. And I haven't shown you how to get there yet. So think about setting it up the way we did above it. How do we set it up? What are we looking at? The 7 to
How?
some power. We don't know yet. Then it equal 343. So think through the powers of 7, which you can use your calculator for. 7 squared is 49. That's one we should hopefully know. 7 cubed. That's how we're going to use the calculator. Check the right powers in 7. At this point, we should be giving you things that come out either tidy or as numbers that we can figure out like that. So it's either going to be things we know or things that are not like 2.874. We're going to give you whole numbers or like logical fractions. We will not be raising pi as an extra.
I know, I just
I heard it. I heard that one pop in your head. All right, one more like this, then we'll look at 6, and then we'll look at those problems at the bottom. So 10, very, very similar. We have log base 3 of 27. How are we going to figure out the answer on this? Base of 3. What else?
The power of unknown.
To the power of unknown. You can put it as a box. You can put it as a question mark. You can put the letter P. I don't care. I kind of like doing it as a box. And that's going to equal our 27, that argument. So we're trying to figure out what that power is going to be. 3 to what power is 27? 3. 3 cubed gives us 27. So log base 3 of 27 equals 3. So it's almost logic puzzle-y at this point, stage of it. Okay, I'm going to put up number 6 real quick just because we were a little stuck looking at those ones. Just glancing through. So let's look at log base 9 of 3. Just because it came up in our conversations, and this one's a good example of it. Doing this one the very, very same way, where we look at our base of 9 to the I don't know what power equals 3. 9 to what power is 3? How do we make things smaller with power?
Fraction.
That's when we're going to get the fraction roots. So if it's going smaller, we're going to get our fraction roots. Because how do we get from 9 to 3 if we're not thinking exponents?
We divide it by 3.
I was like, yeah, we could divide. We could square root. Aggressive gooses. So the one that we tend to think of that's related to our exponents is that our square root of 9 equals 3. Another way to write square root, and we talked about this at the very end of first semester, is with our fraction roots. Because that 2, that denominator, that's our index on the root. Okay, so if we're trying to make it smaller, that's when we're going to have the fractions. It is not going to be a super common thing. That is not what we're focused on here. But just since it came up in conversation, I was going to touch on it. Just so I didn't go with, ignore that. Because I hate when teachers say that. Like, no, I'll give you an answer. We're just going to also talk about why I'm not going to focus on that right now. Because, ew. Okay?
So it would be 1/2.
It would be 1/2. Correct. We are, again, really not going to have fractions be a majority of the answers. If you are getting fractions repeatedly, stop and check in because it should, for the most part, be whole numbers. That would be like an extra challenge problem. And that's why I picked the ones I did for us to do because I'm like, good chunk of these actually have fractions and negatives and gross things. So I wanted us to see what we were doing without that extra challenge bit of it. So then the reason we have these are those bottom 2 questions on the page. So the reason we start having logarithms is for things like this. This is apparently a for real thing in photography. Honestly, you usually put it in like a little app for it to tell you things. It's that some sort of, I don't know. I'm not a camera person, but like f-stop settings and there's formulas.
I just use the camera to take pictures.
Yeah, if you get into like the bougie lens and the adjustable setting, blah blah blah, with all the dials, usually you put it in a calculator that's like my photo camera. This is the settings I get, and this is what you should blah blah blah. But this is what the apps are doing. So the setting N depends on the amount of sunlight P in this formula here. So N equals log base 2 of P. They say the sunlight is measured at 16 Which variable is that going in for? So we've got something is 16. Which piece of our equation is going to be 16?
P.
Mm-hmm. Yeah, because what we have is that the amount of sunlight is P, and then the amount of sunlight measured is 16. So to me, that says that P is 16. So what that means is if I look at that equation, that formula, we're going to have our N equals log base 2 of 16. So if we're trying to figure out what N is, what should we do?
Base of 2 to the power of the unknown.
Mm-hmm. Yeah, we've got a base of 2. We've got our power of N, or we can put a box, but we're trying to solve for N, and that's going to equal our argument of 16. So 2 to what power is 16? What is N going to equal?
4.
So she would put it on setting 4. Totally know what that means as far as the camera goes. Totally. I definitely do not only use my iPhone for every picture I've taken in the last 10 years. Okay, so these kinds of formulas are why logs exist, is because technically if we're looking at something like this, there's not a way for us to do it in the calculator if it's not something that's easy peasy. So we're starting with things that we can do mentally now. Show us how to do it in the calculator later, but like we're just figuring out what's happening right now. So being able to figure out an exponent is why we have these. So let's look at the next one. We've got at Earth's surface, the air pressure decreases for each mile of altitude. And atmospheric pressure is modeled by that equation, P equals log base 4 of x, where x is the altitude in miles and P is the pressure. So we are asked to figure out how many miles it takes for the pressure to be 7 atmospheres. So which piece of our formula do we know?
Well, 7 atmospheres would mean 7 miles.
Is that the miles?
Oh, wait, no, that's the pressure.
That's the pressure. So that is the P. So we have this. Make sure we're being careful when we substitute pieces in, because that's this guy here. So we're going to write our equation here as 7 equals our log base 4 of x. How do we find x? What do we do? How can I? My base of 4. Yes. Our power is 7. And that's going to equal our x. So we're switching things around using that BPA log BAP.
16,384.
So our x would need to be 16,384 miles. Which is a lot, because that's up. It's a lot. But this is where these problems are coming from, is being able to solve for pieces that are inside these formulas, being able to solve equations like this. Because what if it wasn't that the sunlight was measured at 16? What if it measured 15 here on this guy? Or what if it was something that was like 9, not a perfect power of 2? So working towards being able to solve this. We will get to the point where we can type these all into a calculator and we're going to get super gross decimals. We're just starting with things that are stuff that we can see so that we know what voodoo is happening in the calculator. Because sometimes I know it does feel like the calculator's doing some magic. But we're going to not let it be magic. We're going to figure out the pieces. Okay? So we'll have more like application problems a little bit later once we know how to do stuff that's a little bit more decimally. Tomorrow, though, we're going to move into a very different part because tomorrow we're going to do a little bit of graphing.
Oh, how fun.
Honestly, not that bad as long as we remember how we set up our exponentials. Because, remember, our exponentials and our logarithms are inverses. So we're going to use that tomorrow when we start looking at graphs, okay? So you guys are actually going to get 10 minutes where you guys can work on stuff. Homework 1, you guys can now do, I think, everything on the front except for the bottom question. And we'll do the graphing stuff starting tomorrow. Tomorrow and Thursday we're going to do graphing because it takes a little to get used to it, but once we're used to it, it's all right. Okay? So, yeah, that's kind of the vibe. We are going to do a skills check on next Wednesday. Next Thursday is the career speaker day / college fair / day before spring break.
Next Thursday.
Mm-hmm. 27 is a Thursday. 26 is a
Okay.
Wednesday.
'Cause, yeah.
27 is the career speaker day / usually college fair /
I don't.
I'm thinking about doing the student basketball game on that day. It's a whole lot.
I get the first part, but I don't get the second.
What is the base on ln?
E.
Natural. It's the natural log. Naturally.
Natural.
Oh.
Naturally.
Okay, that makes more sense now.
It's
I
a
had to
pun.
process that.
It's a
Lame dad, natural.
Oh, they only get worse.
Hold on, how are we supposed